Hello, everyone. My name is Dr. Kohli. I'm a first-year master's student working with Dr. Sue Peters and Dr. Laura Brunson. My study focuses on the stroke population to explore cortical activation, standing balance, and fatigue. So why study stroke? Well, every year in Canada, there are over 50,000 new strokes. That's one stroke every 10 minutes. And approximately 50% of stroke survivors have trouble performing activities of daily living due to hemiparesis, which is weakness contralateral to stroke hemisphere. Among other activities, walking can also become limited due to increased fatigue levels and reduced postural control. So a goal of rehabilitation may include training standing balance. We also know that stroke can alter neuronal activity in the affected brain region, and rehabilitation can potentially change cortical activation patterns in patients. And since cycling uses a similar rhythmic pattern as walking, FES, or functional electrical cycling training, could prove to be a practical addition to traditional treatment and potentially change brain activation for patients who cannot stand or walk. So the main question I'm trying to answer is whether functional electrical cycling training can change cortical activation patterns, improve balance, and decrease fatigue in patients with post-stroke hemiparesis. So let's get to the how. From April to September of 2022, 30 inpatients from Parkwood Research Institute would be recruited to participate in the study. Inclusion criteria would be first incidence of stroke and presence of hemiparesis. Ideally, we would want patients admitted into the study as soon as possible after their arrival to Parkwood. The FES intervention protocol would be for 30 minutes, twice a week for 4 weeks. And to measure cortical activation, participants will be examined with functional near-infrared spectroscopy. Specifically, our lab is using the Portalite FMIR system. And this system would be used bilaterally over the prefrontal cortex during two balance tasks. For stroke patients, activation of neural structures, such as the prefrontal cortex, have also been noted during walking. So it is entirely possible that cycling motion could activate similar cortical structures, leading to improved lower limb motor performance. Here's a picture of me on the current FES bike we have access to at the Parkwood facility. And to the right is an example of the visual feedback that participants would receive. FES actually has many benefits, ranging from increased muscle strength, aerobic capacity, and cardiopulmonary function, to activation of paretic muscles and minimization of complications due to immobilization. The electrodes that would be placed on the participant's leg would deliver a low-level electrical current, either to the nerves that control muscles or directly over the end plate of the muscle system. Balance tasks, a double leg stance and a semi-tandem stance. The primary outcome measure is change in cortical activation during the two balance tasks from pre to post. And rating of perceived exertion, the modified fatigue impact scale and fatigue severity scale would be used to document fatigue levels during FES intervention. Here you can see the Portalite system that we currently have access to in our lab. The battery pack is in my pocket and the device is transmitting all the data to the laptop via Bluetooth. The system can detect changes in the levels of oxygenated hemoglobin, shown in red, and deoxygenated hemoglobin, shown in blue, as well as total hemoglobin in the cortex. For the analysis of prefrontal cortex activation, the oxygenated hemoglobin changes between rest and task will be used. The level of activation between two balance tasks would also be compared. To make sure we get standard measurements from balance from pre to post session, an outline of the participant's foot placement would be drawn on a piece of paper and will be used in the post data collection session. So what do we expect to see? We predict an altered cortical activation pattern with potential increase of cortical activity, a decrease in fatigue, specifically the mean severity of fatigue in participants, improved standing balance through better performance in both balance tasks, and finally demonstrate that FES could prove to be an effective addition to traditional treatment and will likely alter brain activation in patients with post-stroke hemiparesis. So to sum up, an enhanced understanding of functional rehabilitation training may benefit Canadians through increased independence and overall quality of life. Thank you for listening, and thank you for your time.